All right, guys, we are in section 2 of chapter 3.
Yep.
And if you remember the last video, we were talking about transversals, which is just a line that intersects at least two other lines. But it creates a bunch of angles, creates 8 angles. And so there's all kinds of relationships based on those. Seems kind of odd, but they're just those relationships that are set up. And so, but if you'll notice, this section is titled Use Parallel Lines in Transversals. And so now things, which it's spelled wrong, I just noticed, that should be transversals, should be another S in there after the R. Once we get parallel lines, there's all kinds of specific relationships that get set up in terms of congruent angles and so on. And so we're just going to go through those.
I think it just kind of makes more sense after today.
It does.
It's a little bit easier to visualize.
In fact, it's a little bit of a problem in a way because most students always think it works this way and don't think about the lines not being parallel.
That's
so you have
true.
to be a little bit careful with that because this is so much easier. You got to be careful. This is not always the rule. This only works when the lines are parallel.
Yeah.
And so got to be a little bit careful
It's
with
a whole
that.
law detachment thing. Because of this, I can conclude this.
Yeah.
And
it goes and goes and goes
Yeah.
in this one.
Yeah.
Yeah. So here's the rule. Actually, it's
Bunch of rules.
4 rules.
4 rules, yeah.
Yeah. If 2 parallel lines are cut by a transversal, so the whole condition here is that pink right there. The 2 lines have to be parallel now, and they're cut by a transversal. Then there's lots of things that happen with those combinations of pairs of angles that we were talking about in the last video. Corresponding angles end up being congruent. So again, we talked about corresponding angles where you could take one of those angles and just kind of slide it down to the next intersection. Well, it makes more sense now because they are congruent.
Right.
And so one can just fit right on top of the other one. And so remember, corresponding angles are angles that one's interior, one's exterior, and they're on the same side of the transversal. And so that's why there's not an alternate in the name, and that's why there's not an interior or an exterior in the name, because they don't fit any of those. So, okay. Alternate interior angles.
They're going to be congruent too now.
And that kind of stems from some linear pairs going on and supplementary angles going on. If we have to go through and prove this, but alternate interior angles end up being congruent as well if we have parallel lines. And so because of that, alternate exterior angles end up being congruent as well. Kind of the same thing, they're supplements. And so, so all these angles end up being congruent. Corresponding, alternate interior, alternate exterior. Okay? But we do have a 4th rule, and this one stands out from the other ones. And if you'll compare to our list from the last video, we have one more pair that's not showing up here. And so those same side interior angles or consecutive interior angles that we talked about before, those don't end up being congruent. They couldn't, because one's obtuse and one's acute. They end up being supplementary, always. They always add up to 180 degrees. So consecutive interior or same side interior are always that way.
I think the big shift here is last section, we just wanted you to identify which ones were which ones were the alternate interior, which ones were the alternate exterior, which ones are corresponding, which ones are consecutive interior. And now we want you to understand something about them when they're parallel and cut by a transversal. And that's that corresponding alternate interior and alternate exterior all congruent, and consecutive interior are supplementary.
Yeah.
So we're just kind of taking it one step further and kind of just getting a little bit more specific here. So just write it down right now, and when you look at the next slide, guys, it'll make more sense. Just if they look, chances are they are. You just have why they are.
Right. Yeah. Yeah. Parallel lines to set that up. So.
Yeah.
So we have a diagram. We're going to see this diagram over and over and over again now.
I mean, used to this, guys.
Yeah. So we have parallel lines here.
Yeah, got end are parallel to one another, and so you see the 8 angles that are created there. And what's kind of cool about this, to kind of make it a little bit easier, you see that angle 1, 4, 5, and 8 are all in blue to represent all the obtuse angles, and then you've got angle 2, 3, 6, and 7 that are all in red, and those are all of your acute angles. So just kind of keep that in mind, because it's going to be a good strategy to kind of identify, hey, there's something about these obtuse angles, and there's something about these acute angles. How can I use that idea to help me identify what's what? So if they're going to give us a number here, 112, and so
that's what's kind of cool about this.
Yeah.
All you need is one angle
All
out of
you
the
need is
8,
one. That's
and you
right.
can figure out all the other ones.
Right, and there's a lot of strategies to use here. We can even use strategies from previous chapters to do this, but for the sake of understanding alternate interior, alternate exterior, consecutive interior, and corresponding, we're going to kind of be able to negotiate this and come up with the other angles here without doing that. So if I look at that 112 degree angle, well, the first thing, really the only other way, if I just want to use these new ideas, is I can say, okay, if angle 1 is 112, then angle 5 must also be 112 because of the idea of corresponding angles are congruent. You know,
You can slide that one right down on top of, you can slide one right down on top of 5.
that's right. I
So
mean,
they're corresponding.
exactly, they're corresponding angles. So I can say that angle 5 is also 112. Now, I don't know if it comes in
No,
or
it
not.
doesn't.
Okay, so now that I know that angle 5 is 112, that's too bad I have my little dealio to type that in
Yeah.
there. Well, if I look at angle 5 being 112 now, well, then if I look up at angle 4, what rule, I mean, let's face it, we know that all the blue ones are going to be 112. Let's just
Right.
accept that
But we
fact.
just want to know the
Yeah,
new rules.
we want to know the new rule. So if I look at angle 5, what relationship between angle 5 and angle 4 allows me to say that those two angles are congruent? Just understanding that they are, guys, one thing, but being able to back it up with a fact is the important piece here.
Yeah.
And so when I look at angle 5 and angle 4, I can say, okay, angle 5 and angle 4 are congruent based on alternate interior angles. So, they're on opposite sides of that transversal, on opposite ends of the parallel lines, and so they're all alternate interior. So now that I know that angle 5 and angle 4 are 112 based on alternate interior, I'm going to go back to angle 1 and I'm going to go back to angle 8. And what rule that we haven't talked about, Mr. Scritchell, allows me to say that angle 1 and angle 8 are congruent?
Well, the only rule we haven't used, other than the supplementary one, is alternate exterior, and those angles do end up being alternate exterior angles.
There you go.
Okay. One is on the outside of the two lines, 8 is on the outside of the two lines. One's on the left, 8's on the right, so they're on alternate sides, so they're alternate exterior.
So we focus in on all the blue ones, guys. Let's figure out how, without using the supplementary rule, we could figure out what the red angles are. And so if I use my idea of consecutive interior angles, I know that if angle 4 is 112, then angle 6 must be the difference between 180 and 112.
Because they have to be supplementary.
They have to be supplementary. So if I take 180 and I minus it by 112, or I subtract it by 112, that gives me, what is that, 68? So now I know that angle 6 is 68 degrees. So now that I know that angle 6 is 68 degrees, I can kind of use a bunch of these transversal rules to come up with the other one. So if angle 6 is 68 degrees, I can go up to angle 2 and say angle 2 is congruent to angle 6 because of corresponding angles. Then I can go back and look at angle 6 again and say angle 6 and angle 3 are congruent because of alternate interior angles. And then if I use angle 2, the fact that I know that angle 2 is 68 degrees, I can jump down to angle 7 and say that it is also 68 degrees because of alternate exterior angles.
Right. There's lots of ways of going about this, but we were trying to use the new rules for all of those. Yes, you can use vertical angles. Yes, you can use linear pairs to be supplementary. You can use all that stuff, but we just want to make sure you know the new rules here. So, anything else there?
Nope.
Okay. So let's put this into practice here. Now this diagram is a little bit harder to see maybe. Again, we need to remember that the little triangles, little arrowheads, line up with parallel lines. So the two kind of going off to the right here have a single arrowhead on them. So those two are parallel. The two that are kind of going off to the left have two arrowheads on them each. And so those two are parallel. And so now we just have to look for some of our angles that we have. Now, the other clue here is the fact that the 14x minus 10 and the 5x both have an x in them, the same variable, and they do end up lining up with the lines that are parallel with the single arrowhead on them. And so we're going to work with those first. And so we need to see, kind of ignore the rest of the diagram, see the two lines with the single arrowheads, and they're cut by the one transversal that hits the other side of the 5x angle and hits the other side of the 14x minus 10 angle. And that's critical that you see what lines are creating the sides of the angles. And so if you see that, because that's the transversal, those two end up being same side interior angles or consecutive interior angles. Okay, they're both above that line and they're in between the two lines that are parallel. And so because of that, they are consecutive interior or same side interior. Therefore, our rule says that they are supplementary. And so we're going to set up an equation where we add those two together. 14x minus 10 and 5x and set it equal to 180, because that's what it means to be supplementary. And so we're done with the geometry. Now we're into algebra. We need to be able to solve that equation. So 14x plus 5x is 19x. We could add 10 to both sides and get 19x is equal to 190. Divide by 19, and x is equal to 10. And even though we didn't have instructions here, the instructions should have been find x and find y. Now, how could we possibly get the 2y then?
Well, I'm guessing that now that we know what x is, we could plug x back in to, well, there's a couple different ways to do this.
Yeah,
I mean,
are.
you could go back and use corresponding angles here if you wanted to do that. Or you could go through and use vertical angles and then do same side interior again.
Right.
And I don't remember which way they go in this PowerPoint.
I'm not sure.
Well, let's see. I think they go.
I think corresponding would be easier.
Yeah, I mean, if you took x and plugged it into that 5 down there, then you get 5 times 10 is 50. And if you look, that angle right there looks a lot like the angle over there on the other side. The 5x and the 2y are both acute angles. And if you look, all right, it's really kind of hard to see how this is all working out to where those are corresponding angles, but they are.
Well, not those two necessarily directly, but they would end up being kind of almost a transitive property anyway. If you slide that 5x straight up above the 14x minus 10,
Oh, that's true.
then they would be corresponding angles, and that would be another reason why they'd be supplementary to prove that other thing that we just did, the equation we just did. But then once you do that, then you can switch to the other two lines being parallel with the double arrowheads, and then the 5x and the 2y, those two angles would end up being corresponding angles as well. And so because that's 50, that top angle up there would be 50. Because that top angle is 50, the 2y has to be 50 because they are corresponding angles and they're congruent. And so we could set, I think that's the way that they do
No,
this.
they don't. They went
Oh,
vertical.
they went the other way. Okay. So the 14x minus 10 we'd have to plug into.
Right, so if you plug in the 10 into the 14x minus 10, 14 times 10 is 140, minus the 10 is 130, and then by the laws of vertical angle, or by the rule of vertical angle, if the right side is 130, then the left side is 130, and then they use same side interior again to say that 130 plus 2y equals 180 degrees. Subtract the 130 over to the other side, and there's that, and then which would be 50 again,
Right.
which was what Mr. Scritchfield said a few minutes ago,
Right.
by corresponding angles. Then you divide by 2 and you get y equals 25.
Yeah.
You know, the challenge here, and this is, it's interesting because you watch Mr. Scritchfield and I, we both see this two different ways, but we arrive at the same place. And the idea here is, guys, is you just got to learn how to unpack these drawings a little bit and kind of pay attention to things that are going on and be able to derive at some conclusions.
As long as you follow the rules, there are multiple ways of getting to the solution.
Exactly.
You just have to follow the rules.
Exactly.
So, okay. And so we're going to finish up here with one similar to this, a little bit easier, but similar to this for you to do, and we'll check your answers in class tomorrow. So a little bit of practice here, and you try to find x and y in this diagram. And again, the key to that is seeing which two lines are parallel and which line is a transversal for the specific angles you're looking at a particular time. So kind of like the last one in a way.
And just on this one specifically, guys, a set of parallel lines could have more than one transversal on it.
Right.
You know,
That's
and
what's
so,
going on here.
Yeah, so you've got one kind of, you know, taking place going from left to right, and then one that's almost going just kind of almost vertical. So
see if you can figure out what x and y are. Let's have that problem done for class tomorrow, and we'll look at that together. All right? Okay. Hopefully this is cementing up a little bit. Hopefully we didn't make it more confusing. I don't know. But practice is key to this.
Yeah.
We're going to do a ton of these kinds of problems, and so we'll practice tomorrow in class.
Yep.
So we'll see you guys there.